right, welcome back. We're going to jump in and do Unit 3, Section 3 today. And this lesson is going to be really familiar, or sound familiar, to the one we just did the other day, because it is literally the converse of last lesson. So here's what happened last time. Last time I said, you know what? If we have two lines crossed by a third transversal line, and the two lines are parallel, then all those cool mathematical relationships happen, like same side interior. Oh, matter of fact, I got a cheat sheet. So again, just a real quick recap of the last lesson. The last lesson, you got to listen to the wording because it matters. The last lesson said if these two lines are parallel, then these cool relationships happen mathematically. We have same side interior angles that add up to 180. We have alternate interior angles that are equal. We have alternate exterior angles that are equal. And last but not least, we have corresponding angles that are equal. So let me just say that one more time again so you hear the difference. If the lines are parallel, then we have these four cool relationships. Today, guess what we're going to say? Today we're going to say the converse of that. We're going to say if we have these four cool relationships, or at least one of them, then the lines are parallel. And some of y'all saying, Mr. Mack, you just said the same thing over again. No, I switched the order, right? First time I said parallel, then cool relationships. And today I'm going to say cool relationships, then parallel. So that's what today's lesson is all about, is proving that lines are parallel. So y'all ready to jump in? I'm going to refer to this cheat sheet several times because this is the whole first half of Unit 3, these four relationships. So if you've got them firmly established in your brain and know that the weird one is same side interior because that adds up to 180, the other three are all equal relationships, you've got the bulk of this unit, all right? So let's just jump in. And I am going to kind of rip through these first couple of slides because they are literally just the converse of what we did the other day. So here we go. First up, we got the converse of corresponding angles. And as I just showed you, corresponding angles, that's one of those equal or congruent relationships. So if you've got corresponding angles that are congruent, then the lines are parallel. Boom. And just to remind you about corresponding, it's a fancy word that means matches up with. So if you look at this group of angles up here, there's four of them. I only labeled number 2 and number 4. But if you look at angle 2, in this group, he's in the top right-hand corner. And if you look at this bottom group of 4, 6 is in the top right-hand corner. It means they match up with each other, or as we say in geometry, they correspond with each other, and they'll be equal, all right? Then the converse of alternate interior, again, the int stands for interior, fancy word that means inside. So we want to be inside the parallel lines. Obviously 4 and 6 are inside the parallel lines, and they are on what we call alternate sides of the transversal. So that's if we have alternate interior angles that are again congruent or equal to each other, then those lines are parallel. So there's two ways right off the bat that we could prove lines are parallel if we have those two relationships in place. So I'll give you a second to copy that because I know I ripped through it pretty quick. So you're hitting pause and we're back. We're moving on to the next two relationships. Okay, it's the converses, like I said. I'm going to skip this one for a moment because he is the weird one. And I'm going to go to the converse of alternate exterior angles. So if you look at this beautiful picture, exterior angles, now those would be ones outside of the parallel lines. So 1 and 7 fit that category. They're definitely exterior, 1 and 7 are. And they are on alternate sides of the transversal. 1 is over here on the left-hand side, 7 is on the right-hand side. So they're alternate exterior. And if those happen to be congruent or equal, again, that's another way to prove that the lines are parallel. And then the last one, all right, he's technically the third one, but the last one I'm going to talk about today is the weird one, the same side interior one. So if the same side interior angle, so once again, I'm back inside the parallel lines, or lines who are potentially wanting to be parallel, the ones on the inside, and they're on the same side of the transversal. Oh my goodness, what did I just do? Oh my God, how'd that happen? Okay, whoo, sorry about that. I'll edit all that out later. So if they're on the inside and on the same side of the transversal, like 3 and 6 are, 3 and 6 are both on the right-hand side of the transversal, and they're on the interior, and they don't need to be equal. They need to be supplementary, which is that fancy word that means they add up to 180. So you want these guys to add up to 180, and if they do, then your lines are parallel. So that just recaps this beautiful cheat sheet, man. Again, if you've got this down, you're well on your way to doing well on this unit test, which for you online students, that window is going to open up roughly like around 2 o'clock on Wednesday. So a week from today. Today is Wednesday the 16th. So that window for you online students will open up Wednesday the 23rd. Jordan! And about 2 o'clock, and then I'll keep it open for 2 days, like an A day and a B day, if you like to keep to that schedule. So it'll be open for you online people Wednesday, and then till about Thursday night at 11. I'm usually making it till 59 p.m. So you'll be taking it on Wednesday and Thursday. The in-person people are taking it on Tuesday and Wednesday, just if you're curious. Okay, so that takes care of those 4 relationships, and now we're going to do some sample problems, all right, just to see that you've got this in your brain. So they're going to ask the questions a little differently than they did on worksheet 3-2. They're going to ask which lines would be parallel due to the information given. Now I've got like 5 examples here. I think we're just going to do the first 4. Everybody in person today thought 4 examples was good enough, and you can have 1 if you want to practice with your friends. So here's what's going on. You got this beautiful diagram. I would take a few seconds and draw this right now, and you're going to use it 4 times. So when we mark on it here in a minute, you might want to mark lightly on it so you can erase if you want. So what we've got is we got a line A and a line B. That's a cursive B as in Bravo, and they're going like this. So what we're trying to do is decide which lines are parallel, if any. All right. It's possible that none of the lines are parallel, but our choices are A and B parallel, and this is a cursive L and a cursive M, as in Lima and Michael. Are these 2 guys parallel? All right. Now you're looking at the picture and you're saying they all look parallel to me, Mr. Metcalf. And again, you don't want to go by looks unless I explicitly tell you you can go by looks in this unit, and you can't on this one. You cannot go by looks. You got to go by this information they provide. So here we go. The first one says, if angle 1 is congruent to angle 2, which lines would be parallel, if any? So I'm gonna go ahead and mark that. I'm gonna mark angle 1 being congruent to angle 2, and as we learned in a previous chapter, you do that with a swoosh. So I'm gonna put a red swoosh on angle 1, a red swoosh on angle 2, and now I look to see which lines would be parallel based on that information. All right. So first thing I'm gonna do is I'm gonna check lines L and M. All right, here we go. We look at L and M, and I've got some markings on on line M. I got a swoosh here and a swoosh here, so I got a lot of information about line M, but I don't have any information about line L, not in this problem at least, all right? Because all I know in this problem is those 2 guys are the same. So I don't know anything about L. I know some stuff about M, but that's not enough. So please, that's just how easy it is. If you don't know anything about one of the lines, those 2 guys can't be parallel. Not beyond a shadow of a doubt, at least. So forget about L and M. So let's take a look at A and B. Could they be parallel? Well, you got some markings on line A. You got a swoosh on line B, so that's a good sign right there. So I'm going to think that it's probably A and B that are parallel. Now, to make sure, they have to satisfy one of these four relationships. Now, the fact that they are equal to each other, indicated by the swoosh and the information that was given to us, we can sort of get rid of same side interior, because that's the one doesn't really care about being equal. He cares more about being equal to 180. So forget about him. He's out. So we look at the other three. We got alternate interior, alternate exterior, and corresponding. If those two angles that are the same are one of those three, then lines A and B are parallel. So let's look at them. Oh, another trick I've been telling my students is once you find out one of the lines is not really involved in this problem, then try to ignore it or cover it up if you can. And line L is that line. He's not part of this problem. So I'm going to pretend like he's not there, and you can try to do that at home. And I look at these two guys and I think, which relationship is that? And I noticed one of the guys, angle 1, is actually inside the parallel lines, and angle 2 is on the exterior, and there's only one relationship that has one person on the inside and one person on the outside, and that's corresponding, right? Because he's the only one that doesn't have like an interior, or an exterior. That's because one of his angles always has to be on the inside and one of them has to be on the outside. So it is corresponding, by the way. And to verify that, angle 1, if you look in this group of angles, angle 1 is in the top right-hand corner. If you look at angle 2 in this group of angles, he's in the top right-hand corner. So they match up, or as we say in geometry, they correspond. So the answer to this one would be lines A and B are parallel because they have the markings. So we're going to say line A is parallel to line B. And that's because, and I'll use a little text talk right here, B/C, that means because for all you texters out there, because of corresponding angles, all right? So that's the first one. So there's my justification, corresponding angles. Technically, if you want to say the converse of the corresponding angles theorem, that's makes it even more special, but this is good enough for me. All right, so I've processed the first one with you. I want you all to try the second one on your own, but I'm going to give you a little hint because the visual part is so important. I hope that doesn't bother you all that the height of my screen cuts off the top of my head most of the time. It's not all about looking at me, it's about the screen. So it doesn't bother me, but I know it might be kind of weird, you all watching at home, and my top of my head's cut off 90% of the time. So I hope that's not throwing you all off. So in problem 2, and I'm going to color code these. I used red on the first one. I'll switch over to blue on the second one. In the second one, they say, what lines are parallel if angle 6 was congruent to angle 7? So let's find 6 and 7. Here's 6, so I'm going to give him 2 blue swooshes, and you all can just do 2 swooshes at home. If you got colored pencils, that'd be great. You can use that. And then 7 is congruent to him, so I'll give him 2 blue swooshes. And again, we want to find out, and I'm going to let you pretend like you're doing it on your own after I did the visual part. And again, remember what I said, whatever line is not involved, kind of ignore him. And these 2 lines and this line are definitely involved with the blue swooshes, so it's line A that's not involved. So I kind of gave away the answer. I didn't mean to do that. But you don't really, in the second example, I'll call it the blue example, you don't really know anything about line A. So forget about A and B being parallel. We just don't have any information on A. No blue information, at least. So we're going to look at lines L and M. All right? So we're looking at lines L and M because that's where the swooshes are. And, oh my goodness, I keep doing that. Let's see. My fault. Okay, so I got these L and M, and I'm going to ignore A. And when I do these 2 double swoosh angles, are they one of the 4 relationships? Well, if you look at them, once again, 6 is inside the lines, 7 is outside the lines, and that's usually the dead giveaway that it's corresponding. So the lines that would be parallel in this one would be the L and the M. And this time it's based on the fact that the angles we know are congruent are the corresponding. So this time it's line L is parallel to line M, and that is because of corresponding again. Wow, okay. I hope the next one is not corresponding, because I think we've covered that one twice now. So let's move on to number 3. What if angle 8 is congruent to angle 3? So let's switch over. I'm going to use a green. How about green? Okay. So 8 is congruent to 3. So I'm going to triple swoosh 8. 1, 2, 3. And then I'm going to triple swoosh 3. 1, 2, 3. Okay. So first things first, which lines would be parallel based on that information? The green triple swoosh information. And that would be, okay, we got some stuff here on A. We got some green swoosh on line L. And we got some more green swoosh on M. But no green swoosh on B. So B is the odd man out on this problem. So we're not going to mess with B. Therefore, it's not going to be A and B that are parallel to each other. It might be L and M. All right, because L's got some green swoosh on it, M's got some green swoosh on it. So let's try L and M and see if they are one of our 4 relationships. Again, I keep hearkening back. Oh, that's a good SAT word. Hearkening back to this little cheat sheet here. And if you got this in your head, you're ready to go. Do I have one of those? Now, again, it said that they're congruent to each other. Doesn't say anything about 180, so we can kind of eliminate same side interior. So we're going to look at for these other 3. Hopefully it's not corresponding again. That'd be crazy. So I look at 3 and I look at 8, and here's the lines we're assuming are parallel. 3 and 8 are both outside. They're exterior. Hopefully they're alternate exterior, because that's one of our relationships. So, and sure enough they are. 3 is over here to the left of the transversal. 8 is to the right of the transversal. So we definitely have alternate exterior angles. So we're going to say lines L and lines M. All right. So line L is parallel to line M because of alternate exterior angles. All right. Any questions on that? You got to get those 4 relationships like firmly in your brain. That's the whole first half of this unit, so you need to do that. All right, we're going to do one more because this is kind of the oddball one. I think you all probably know what's going to happen, because look what it says. It says angle 5 and added to angle 6 is 180. So there you go. If it's going to be anybody, it's going to be you know who, right? There's only one that says anything about being added up to 180 in this unit, at least. So that's same side interior. So let's see if we got some same side interior. They're talking about angle 5 and angle 6. How about I use a pretty pink color here? I'll use this pink color. So 5 and 6. Now they're not congruent to each other, so I wouldn't use swooshes. That would be incorrect. You don't want to use swooshes because it's not saying that they're equal to each other. It says they add together to equal 180. So I'm just going to mark them by circling them or something like that. So angle 5, I'm going to circle him with pink. And then angle 6, I'll circle him with pink. So that doesn't mean they're equal to each other. It's just I'm just trying to mark them so they stand out. And so the 2 lines we're talking about, well, again, 5 and 6 are up here on L, and they're also on A and B. There's no pink circles on line M, so forget about L and M. It's not those 2. It must be A and B. So let's chickadee check and see if we have same side interior for A and B. And sure enough, you look at 5, you look at 6, they're on the interior, and they're on the same side of the transversal. They're underneath it, right? They're both underneath. So they add up to 180. 180. They're on the interior and they're on the same side. So it is lines A is parallel to line B because same side interior angles. All right. Any questions on that? Man, just shoot me an email. Maybe you went to the Google Meet today. I know Mr. Crabtree did a Google Meet. I think next week the Google Meet is going to be on Monday because the first people taking the test will be Tuesday. So you can make it, jot it down, mental note, whatever. The next Google Meet, the one to get you ready for the test, will be Monday. And that date would be the 21st, I think, September 21st. All right, so moving on. We're done with that screen. Let's move on to the next. Now we throw in some algebra. All right, we got some algebra. We got some. That is. Oh, by the way, some students had some trouble with this. That is not a 26. That is a 2b plus 9. And then I had one person think, is that a Roman numeral 3? I'm not going to do that to you. I'm not going to all of a sudden go Roman numeral on you. This is straight up 111. All right, and it probably should have the degree sign next to it, as should this 55 in the next problem. So that might have made it a little more clear, but yeah, that's a 2b as in Bravo plus 9, and this is a 111. So what you want to do on these is they're saying, okay, what value of the variable would make the lines parallel? So what variable would make those special relationships mathematically work? All right, so if they're same side interior, we would make them add up to 180. If they're any of these three, we would make them equal to each other to make this work. So let's take a look at what we got. So I'm looking at 2b plus 9 and 111. They're both on the inside, so both interior, and they're on the same side of the transversal. They're both on the left-hand side. So that's definitely a straight up same side interior, which you all know by now is the odd one that needs to add up to 180. So that's exactly what I'm going to do. I'm going to say 2b plus 9. Let's see, where I got some space. I'll put right over here. 2b plus 9 plus 111, not equal to 111, plus 111 should add up to 180. Can you all see that on that? That's light pink color. I can see it on my screen, so hopefully you can. And now the rest is Algebra 1. So let's go ahead and knock that out. I've got a 9 and 111. That'd be 120. And the 2b, trying to make my b's look like b's and not 6, equals 180. And then I think everybody knows what to do at this point. You'd get rid of that 120. You'd subtract 120. And then to be equal, you subtract 120 from the 180. And they'll cancel out over here. You'll have 2b equals 60. And then all you got to do now is divide off that times 2. So you divide by 2 and divide by 2. Cancels that out. And you get b equals 30. Awesome. Any questions on that? I will pretend like we're pausing for a second, and you all will do the exact same thing for the second one. But it might not be the same relationship, so don't just add them up and make them equal 180. That only happens one time out of 4, right? There's 3 relationships where they're equal. So find out which relationship you have in this situation and decide, should I make them equal to each other, or should I make them add up to 180? And we'll pretend like you hit pause and you're working on this, and I'll come back. All right. What did you get for E? Man, I don't remember the answer. I think I think I do know what it is because we did this problem earlier today. But this relationship, I notice, here's my parallel lines, or the lines I'm hoping will be parallel. And I notice I have one guy on the exterior and one guy on the interior, and only one of the 4 relationships does that. You'll notice the top 3 relationships all tell you where they are: interior, interior, exterior. The only one that doesn't is corresponding, because he can't. One of the guys in corresponding has to be inside, one of them has to be outside. So this is probably a corresponding problem, and let's make sure it is. 55 is in the top left corner of that group. 3e minus 2 is in the top left corner of that group. So yes, they match up, or they are corresponding. So let's go ahead and set them equal to each other. And 55 is on top, so I'm just going to say 55 equals 3e minus 2. Some students are bothered by the variable being over here on the right as opposed to the left. You can switch it around if it bothers you. It's no big deal. As long as you switch the whole thing. Don't just bring him over here. You got to bring the 3e and the minus 2 over here and bring the 55 over there. You're allowed to do that in math. That's okay. So I'm going to get rid of this minus 2 first. So to get rid of a minus 2, of course, you would add 2. And then to be equal, you have to add 2 to this side. And we get 3e equals 57. Vroom, vroom. All right. So now all I got to do is get rid of that times 3. So I divide by 3, divide by 3.